This video is for section 9.5. Our objectives in this section are to use logarithms to solve exponential equations and use exponential form to solve logarithmic equations. So the first thing that we're going to do is actually from section 9.4. This is on page 710. It's called the change of base property. And this is something that allows us to evaluate logarithms with bases other than 10 and e using a calculator. So the change of base property states that if I have log base b of m, I can do this on the calculator using the log button. It's log of m divided by log of b. Or I can use the natural log button, natural log of m divided by natural log of b. And so the important thing here is that the base b is going in the denominator of the fraction and the number that comes after the base is going in the numerator. So the way that I would type this in a calculator is using the log button. It's going to open up a parentheses, m, I need to close the parentheses after that, and then divided by log of b. Or with the natural log, it would be natural log m, close parentheses after that, and then divide by natural log b. So we're going to look at example 7. This is on page 711. It says to use common logarithms to evaluate log base 5 of 140. And common logarithms means that I'm using the log button, the log base 10, not the natural log. Although you can use either and you would get the right answer either way. So log base 5 of 140 would equal log of 140 divided by log of 5. So on my calculator, I would type log 140 divided by log 5. And I'd highly recommend doing this all at once just because with these problems there's some rounding that goes on and there's a high probability of having a rounding error, which is going to give you the wrong answer in my math lab if you round too much. So typing it in all at once like this is the best way if you can do that. So if you type this in, you're going to get 3.0704. When you see these in the homework, it'll say to round to 4 decimal places for these problems. So that's where I'm going to round for that one. So you need to obviously make sure that you're rounding correctly with the rules for rounding or it's going to be marked wrong. But that would be the answer for that one. So next you should try checkpoint problem number 7. Do this in your notes, check your answer, and then move on with the rest of the video. So next we're going to look in actually section 9.5 at example 2. This is solving some exponential equations, and we're going to use logs to help us solve these equations. So looking at part A, I can already tell that this is not going to be a nice whole number answer because I know that 4 squared is 16, but there's no number 4 to raise to the power. There's no power that you can raise 4 to that'll equal 15 exactly. So it's going to be a decimal answer that I'm going to have to round. So what I'm going to do here is rewrite this into a logarithmic form. So that's going to be log base is 4 of 15 equals x. Now I do this a little bit differently than the way that the book shows it. The way that the book shows it involves taking logs of both sides, and I think that that's just more complicated. So I usually teach this just as you just rewrite this in logarithmic form and then you can evaluate the logarithm. So x equals log base 4 of 15. Now what I'm going to do in the homework, you're going to see they're going to ask you for an exact answer and then a decimal approximation. And they're going to want you to write your exact answer using natural log, so that's what I'm going to do here. I'm going to use the natural log version of the change of base property. So I can say x is equal to natural log of 15 divided by natural log of 4. And then I would type that into my calculator and get a decimal approximation of 1.95. For these problems in the homework, it'll say to round to 2 numbers after the decimal point. So both of these are going to be, you'll see in the homework, things that you're going to input. For part B, this one is 10 to the x equals 120,000. So when I rewrite this in log form, it's going to be log base 10 of 120,000 equals x. Now for this, log base 10 is just log. I don't need to write the base. So log base 10 I can do on the calculator. So if I just type this in, log 120,000, that's going to be my answer. And I'll do that and get a decimal approximation of 5.08. So next you should look at checkpoint problem number 2. Do these in your notes, check your answers in the notes that are posted, and then move on with the rest of the video. Lastly, we're going to look at example 3, and this is another problem where you're solving an exponential equation, but this one obviously is a little bit more complicated. What I need to do in terms of order of operations here is I need to get the exponent with the base by itself first. So what I need to do is isolate this e to the 0.6x. So I'm going to add the 3 first. That's going to give me 40 e to the 0.6x. So just as if it were 40x minus 3, I need to undo the 3 first and then the 40. So next I'm going to divide both sides by 40. And that gives me e to the 0.6x equals 6. Once I have it so that I just have the base and the exponent on one side, now is when I rewrite it as a logarithm. This is base e, so I'm going to use natural log. So rewriting as natural log, it's the base is e, so log base e or ln of 6 equals the exponent, 0.6x. And now remember, my goal here for solving is to get x by itself. So the last thing that I need to do in order to get x by itself is to divide. So I would divide both sides by 0.6. So again, on the homework, they're going to want you to enter the answer in 2 ways. One is the exact answer, and the exact answer is going to have the log in it, natural log of 6 over 0.6, and then the second is the decimal approximation. So you would type this into your calculator, and you should get approximately 2.99. So those are the 2 answers that you would input for this one. So next you should try checkpoint problem number 3. Do this in your notes, check your answer, and then move on to the homework for this section.